All right, let's see how, hopefully it works. Here we go. So we are starting with measurement and sig figs today. And the thing about this first unit is that it is extremely, extremely important for the rest of the year. So this is a lot of math, and we do a lot of math with different formulas per unit, right? But the same math, the same stuff that we do right now will be what you do for each different type of math that we put in a unit, okay? So this is the basis for the entire year that we do. So once again, if you feel like, because I've turned the lights off for the video, if you feel like you're dozing off, whatever it is, go stand up in the back. I will try to have frequent breaks so you can work on stuff, but you got to take care of yourself and pay attention however you need to. Okay? So here we go. The first couple slides we're going to get through pretty quickly because what system do we use in science?
Metric.
Metric. We use metric, right? So you all use metric, right? In Italy. So this will be a breeze for you. You're going to think like you learned this in second grade probably, but we didn't. We didn't. Okay. You all are probably super confused with miles and inches, right? But we use metric because that's what everybody else uses. And when we share reports, we share findings. It's just easier if we have them in the same units right away. So metric is the way it goes, all right? So here are all of your base units, all right? Seconds should be good, meters for length. The mass one is where it looks a little bit different because you would guess that it's grams, but it's actually kilograms. Now, if you want to ask me why is it kilograms and not grams, you can, but I'm not going to have an easy answer for you. All right, I'll send you an article. Do you have an answer? Just what you wanted to ask me? I'm not going to explain it. Because it's I asked our AP Chem teacher, he's our ACES, and he didn't even answer, he just sent me 2 articles that are extremely hard to read. So I'll send those to you if you don't have anything else to do this weekend. You can read it and then come back to me. All right? It's not important. It's not important. Just know that kilograms is our base unit of mass, not grams, right? Temperature, Celsius is what you're most familiar with. Do y'all do much Kelvin? Have you guys been talking about Kelvin? Okay. So Kelvin is another scale for temperature. Okay. Anybody heard of Kelvin before? The Kelvin scale? All right. So I can talk about it right now. Kelvin is the absolute scale, an absolute zero scale. Right? Does anybody know what absolute zero is?
Isn't that the coldest readable point?
That is the coldest anything can get. All right? Because as molecules in any matter start to slow down, that's how their temperature cools down. Right? So if you heat up, the molecules inside of you start moving faster. When you cool down, they start to move slower and slower. Ice is still moving, it's just moving a lot slower than liquid water. Well, at absolute zero, all the molecules have virtually stopped. Well, you can't get slower than stopped, right? So that's what we call absolute zero, negative 273 degrees Kelvin. All right? And because it's on an absolute scale, that's actually the desired scale that we should use is Kelvin. And once we get to the second semester, we use that all the time. All right? The amount of a substance is the mole. Next to this, you might want to put like a dozen or a baker's dozen, right? Have you guys ever heard of a baker's dozen? Is how much? 13. A dozen is 12, right? A few, 3. A couple is 2. You guys have heard of those before? That's the exact same thing of what a mole is. It's just a unit of amount. Okay? We use that in the second semester. Once again, I got a whole corner over there dedicated to the mole, but it's just the amount of something. We use it with atoms instead of eggs. All right. Length, I'm not too worried about. It's meters. You can write this down, but you don't need to measure. You don't need to memorize this conversion. Okay, I will give you this conversion if we need to. All right. With this one, we use analytical scales, and we're going to talk about this accuracy with this next slide that's coming up. All right. One of the most useful and ones that you will not be given that you are going to have to remember is the conversion from a volume into a length. Okay? Centimeters cubed, which is length, into a volume. It's a one-to-one. It's very, very useful, very important. It even says it up there. Yes, yes, this is important. So it is important. Okay. But remember this. So if I have a tissue box that's 50 centimeters cubed, what's its volume? 50 milliliters. It's a one-to-one conversion. All right. Just don't forget about this. All right. So yes, good idea to have extra colored pens out, highlighters out, stuff like that. If you want to take detailed notes, which is always a good thing. Okay. So here's where we start to get into the real stuff that is probably pretty new to us. Okay. So when we read a graduated cylinder, right, it appears that there's this bubble or curve. What do we call that curve? The meniscus, right here. The meniscus. Do we read the top or the bottom of the meniscus?
Bottom.
The bottom. You guys have all heard that before. Read the bottom. It appears curved. It's not actually curved. It's just an illusion because of the curved glass of the cylinder. It's not really curved. It's just an illusion. Okay. So what we need to learn here is this part, this plus or minus 0.1 milliliters. That's kind of like an error reading. Like we can estimate up to 0.1. So someone might give 52.8, someone else might give 52.7, someone else might give 52.9. Those are all acceptable readings. That's where that plus or minus 0.1 come from. But how did they get that 0.1 plus or minus error? That's what we're about to learn right now. Okay, some of you can already figure it out. I'm going to start. It might sound a little more complicated than what it actually is, but here we go. All right. So when I look at this curve, this is the 50 line. Would you all agree with that?
Yeah.
And then you have a line here, a line here, a line here, here, a big liner, I guess medium size here, 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 and there's your 60 line. Right? Each line indicates what?
Full point.
0.1, 1, 10, 5, 1 what? So each line is 1 milliliter. You all agree with that? I promise there's a point coming up. Yes? And when you make a reading, you're a scientist, you make the most accurate reading you can and report that most accurate reading. So would you say that this line, this meniscus line, the bottom of it, is 51, 52, 53, 54, 55. So is it 52?
No.
Is it 53?
Sure.
That would be your most accurate, correct? Which is why this doesn't say 52 or 53. It says 52.8. But is there a 0.8 line? So what did they do to this 8? They estimated that last digit. Well, that last digit happens to fall in the 10th of a millimeter range, right? Which is why we can say plus or minus. Does that make sense? All right, let's take it maybe to on a smaller scale. So, have you all seen the real skinny graduated cylinders that measure 10 mil? Okay, super small, look like you're going to break it just by touching it the wrong way. So if that's 1, 4, 5, 6, 7, 8, 9, and there's your 2 line. Each line is equal to what? A tenth, a 0.1. So this tool actually measures 0.1. Does that make sense? Did this tool measure 0.1?
No.
This tool measured 1. So which one is more precise? The smaller one that has more lines on it. Okay? More precise measurements. That's kind of a skill that we need to know. This one costs more money because of the precision of it. All right? But it measures to a lower number. All right? So what will the plus or minus of this reading be? Would it be 0.1?
No.
Because it already gives us that, right? If I have a measurement of, let's say, right there, what's the error range of the smaller one.
Plus or minus 0.1.
Plus or minus 0.01. Because we can estimate to the 100th of a milliliter now, correct? Because this one, is it 1.9? Is it 2.0? It's in between, so maybe 1.95 would be the most accurate. Okay, so this goes with any, this might be a general rule that you might want to write down because it's not specifically laid out in your notes, right? Anytime that we read a measurement, which digit is always the estimated digit?
The furthest to the right.
The furthest to the right. Does that make, so your last digit. So in this case, it was, we said 1.95. Which one did I estimate?
5.
The last digit. Your scale's back here. Your scales that we're supposed to use today, but we're not going to get to today. So on Wednesday, it'll be one of the first things that we do. Your scales measure 0.00 grams. So which one is going to be the estimated one that your scales? What digit does your scales estimate to? The 100th spot. So it's super precise to the 10th. It needs to estimate a little bit to get this last digit. That's still pretty precise when we're talking about what we need to do in here. That's a good thing. All right, so that's estimating measurements. The more lines you have, the more precise your instrument, but the more expensive you have too. So you got to think of cost compared to what you actually need it for. All right, Kelvin we've already talked about. Like I said, Kelvin, your Kelvin scale is equal to your Celsius. Just add 273. All right, or if you're trying to get from Celsius to Kelvin, you just subtract it. Right? We did manipulate the formula a little bit. You can figure out one or the other. We're not going to use that right away, but it will be used quite often in the second semester. Kelvin was just a scientist that kind of came up with a scale and was credited with this. Okay, so here's where we get into your metric conversions. This has been a struggle. Hopefully what I'm about to do will help out with some of that struggle. If you have been taught a certain way on how to convert these, let me know. Because it hasn't been super successful right off the bat, and we'll see how you all do with it. Okay, so here are some prefixes. So the prefixes tell me what factor of 10 I'm in. So your metric system is all off a factor of 10, which is a good thing. You guys heard that before? Metric is off a factor of 10, which makes it extremely easy to convert between your prefixes. Okay, here are the most common that we will use in here. Mega, kilo, deci, centi, milli, micro, and nano. All right, you won't really need, the ones that you'll need to memorize are the milli, centi, deci, and kilo. If we ever use mega, micro, and nano, I will probably give those to you. But we use those quite often because we're either really big or we're extremely, extremely small. Usually extremely, extremely small. Okay? But where this base, this factor of 10 comes from, and you might want to write this down. You guys ever heard the Namak Vice of the King Henry died doing something? You guys have heard that before? Okay, so this is how we're going to do it. King Henry died unusually, and we'll get to that. The use usually where there's some variations in the saying. Drinking chocolate milk. You don't like that? Have you heard of, huh?
It's fun.
It's funny. Have you heard of something else? Did you use something else? No?
We don't use it.
You just memorized it. Yeah. Okay. So this is kilo, hecto, deca, Unusually, so this is called unit, or your base unit. Deci, centi, and milli. Milli. Okay? Yes? I'm not done yet. Just wait until I'm completely done, then you can, for sure. Yes?
That's not matching with the notes, the order.
What's that?
Just the order isn't matching because it's like mixing in with this table here.
There's a bunch in between all that stuff.
Oh, okay.
Milli. There we go. Milli. Yeah, there's some, these are in order. So like mega would be way up here, and there's some in between it from kilo,
Oh, okay.
right? So it's not gonna match up
Oh,
perfectly.
yeah, there's 3 spots
Yeah.
between
Yeah,
10 to the third.
Yep.
10 to the-
So the numbers that are matching up there, like the numbers that you're looking at, okay? And we'll apply these here in a second. So your base unit is 10 to the 0. 10 to the 0 is 1. That's why they're the base units. Does that make sense? 10 to the first. That's right, 10 to the 0. Then if we go up 1, it's 10 to the first. If we go down 1, it's 10 to the what? Minus 1. That means every time, these are in order, so each time I move up 1 or down 1, it's just by a factor of 10. A factor of 10. You gotta keep that in mind. Okay? If I move up 2, it's by a factor of what? 2. If I move up 3, 10 to the third. Same if we move down. So why did we do this? So what you're going to have to do is you're going to have a starting spot, and you're going to need to convert to a different spot in the metric system. This scale, this only works if we go from metric into metric. So I want to go, let's say I want to go from meters into millimeters. Meters. If I want to go from meters into inches, this wouldn't work. 2 different systems. Does it make sense? If I want to go from kilometers into miles, this wouldn't work. 2 different systems. All right, but as long as it's in the same system, we can do this. So how do we do that? Let's say I have 4 meters, and I want to turn 4 meters into millimeters. Okay? The first step, and you all should be writing this down, is to write out the given, 4 meters. And this is going to be great practice for dimensional analysis, which is next unit, right? Well, I want to get out of meters and into millimeters. Would you all agree with that? Which means if I have meters on top here, I have to put meters down here to get out of it. And I want to get into millimeters. So meters goes on bottom because I need to get out of that unit, and the unit I want to get into goes on top, right? So now, what goes in these spots? So I have meters into millimeters. Which one is the larger measurement? Meters, right? So there's going to be a lot more of these than these, right? Yes? Think about that. So how many times did I go, how many steps did I have to get through to get to millimeters? 1, 2, 3. Yes? That 3 tells me how many zeros I put into my measurement. So that what's that saying is there's 1, 2, 3, 1,000 millimeters in 1 meter. So now this tells me that I have 4 times 1,000 divided by 1. Now, the first section of your test, there's no calculator allowed. No calculator allowed. So when I'm multiplying, is this 4 going to get larger or smaller? So when I go to move the decimal, technically it's 4, there's a decimal, right? I have 3 zeros, so I move it 1, 2, 3. 4,000 millimeters and 4 meters. This is the skill that you will have to do without any of these conversion tables or calculator. Just so you know, like, kind of what the end goal is for this unit, or for this part of the unit. All right. So let's go to your homework page on page 3. And let's do number 1. 6.73 kilometers into what? So look, I'm going from kilometers into millimeters. Yes? Is my number going to get a lot bigger or a lot smaller?
Bigger.
I'm going from kilometers into millimeters. It takes a lot more of these to equal one of these, right? So my number should get much, much bigger. Just keep that in mind to see if our answer actually makes sense, right? So if you're paying attention, kilometers on top, which means what comes right here? What unit goes right here? Kilometers has to go right here, so I can cancel them out. Yes? And what am I trying to convert into? Millimeters. So now I know I have a big number and I have a 1 I need to put in here. Right? What is my bigger unit of measurement? Kilometers or millimeters? Kilometers, that's where my 1 goes. So 1 kilometer equals how many millimeters? Well, some of you might already know, but let's figure it out. Ready? 1, 2, 3, 4, 5. So it's that 6 tells me 6 zeros. 2, 3, 4, 5, 6. So that many is, I think it's a million. Millimeters equals 1 kilometer. No calculator. No calculator allowed. So technically, my math problem is 6.73 times 1 million. Oops. There we go. Divided by 1. Well, if I'm dividing, or sorry, if I'm multiplying, that decimal goes where? To the right or to the left? To the right. I'm getting bigger. So, watch. Because this was the confusion I had last time, so I'm glad so I can tell y'all. What I had somebody do was put 6 zeros right here. Is that correct?
No.
That's not correct. I moved the decimal 6 times. 1, 2, 3, 4, 5, 6. And all the blank spots, I put zeros. And then I put my label of millimeters. And there's my answer. That's how many millimeters are in 6.73 kilometers. All right? You want me to do one more, or you want to try a few? Do another one?
What's that? The CG.
Centigrams.
Oh, okay.
Centigrams. Right here. All right, let's do the next one. I don't have them. Thank you. 3.9 liters into milliliters. So liters is where?
Well, it's the unit. It's the base.
It's the base unit. I had some people with issues with that. If you have meters, liters, grams, it goes right here. You start in the middle. All right? So 3.9 liters, well, right away, I should be able to do that because I know I need to get out of liters and into milliliters. Let your units guide you through this. Then I know that which one's larger, liters or milliliters? Liters is larger, so that's where my 1 goes. Milliliters is how many away? 1, 2, 3. So I know that I have 3 zeros. When I do this mentally, not with a calculator, I know that 3.9, I move the decimal 3 times. 1, 2, 3. 3,900 milliliters. Okay? 5 minutes. Go ahead and get done as much as you can. Talk with somebody around you. Check your work with somebody. So then, it's the same way. It's the same way. So let's say, let's go from, which are you gonna do? So number 2, what do we start with? So we're doing number 2 if you're interested here. 4.2 milligrams. That means milligrams go on top, or sorry, on bottom, so they can cross out. Centigrams on top, because that's what I want to get into. That's kind of the rules. When I say let your units guide you guys, that's what I mean, right? So, which one is the bigger unit? Centigrams. So that means the 1 goes to centigrams, and I'm starting at milligrams, and I'm just going up how many?
1.
That means 1, 0. That 10 goes with milligrams. That's saying 10 milligrams in every centigram. Does that sound about right? Yeah. There you go. So now you have 4.26 times 1 divided by 10. Since we're dividing by 10, that decimal goes where? To the left. So this is point to the left one time, 0.426 centigrams. So yes, I have a graphic of this that I'll post on Canvas, but if you want to take a picture of this, you won't get this on your test. You got that? Well, you will get periodical resources, but this you will not. Okay, you will have to, hopefully doing the factor of 10 scale is very easy, and if you write that down, it'll be very easy to memorize. Once again, and then from the chart that you were talking about, this is one, the base is a big one, and then centi and milli. Those are the important ones that you will quite often see. Not promising you won't see the other ones, but those are the big ones, all right? If you want to end in a unit that's higher, then it'll be moved to the bottom. You can talk to people. All right, number 4. Number 4. Read it to me.
5.47
Milli what?
millimeters to meters.
So we start with 5.47 millimeters. We need to get into meters, right? So that means I have millimeters on the bottom,
Yes.
meters on top. Correct? Which one is my bigger unit? Millimeters or meters? Meters. There's my one. Now how many millimeters are in 1 meter? Well, I start at milli. 1, 2, 3. Tells me there are 1,000 millimeters in every 1 meter. Which means I know I'm going to move that decimal spot 3 spots to the left. 1, 2, 3. So it's 0.00547. And then meters. Guys, when you're asked these, don't forget your units. Usually your points are broken down into about 3 or 4 different points, and your unit, correct unit in your answer counts as a point. That's your base unit. Like, so you're not going to see up there grams, liters, or grams, liters, meters, because those are all base units. So gram goes where on this scale? Where'd your gram go? So, and this is the first one, right up. Guys, your base unit, the unit that goes with the 10 to the 0 are going to be grams, liters, and meters. Everything else is kind of scaled off of those base units. Does that help? So I don't know if you need to add that to your picture if anybody took it, but you need to know that. Yes. Where'd you get the point one? This is just times 10. Yeah,
I
not.
see what you mean. So,
Good question.
yeah, I didn't use my note.
No. Because your decimal's there
What I did.
before the 5.
Here, I'll rework
If you move it to the left 3 times,
six.
see what I'm saying? 1, 2, 1, 2,
Alright.
3.
For that we had our.
Actually, you got an extra 2 zeros.
Oh, so I was right. So,
No, because you have 925 grams to kilograms, right? And you divide by 1,000,
and if it ends up being
which means you moved it to the left 3 times. So here's your decimal.
so
1,
it's fighting over
2, 3.
I don't really care. This is solar, so I have to get it like.
Does that make sense? You got it?
So if there's, if grams are bigger,
Yep, answer is 9 days more. Go for it. I didn't even know what I was doing.
wait, no. Wait, so 1 kilogram equals 1,000 grams. So it would be
I had one more.
Oh.
All right, we got to move on. I'll give it another 30 seconds because some of you I think are getting to the point to where you think you got it fairly decently, maybe a little, quite a bit more than you had 5 minutes ago. So finish up what you're on, don't start a new one. Once again, I'll post a graphic of this on the Canvas, but it's not going to be it's a generated graphic, so it doesn't look like this. This is a simplified one. Okay, go back to your notes. I'm not going to pull, yes. So that one we'll talk about next class. If you want to try by using the same kind of steps. But, so like number 9, if you look at page 3, number 9, that's what I was talking about where you're converting from one system into a different system. Everybody see number 9 or look at number 9 on page 3 where it's centimeters to inches? That's where this doesn't really work because you're converting out of the metric system. You might be able to use it a little bit to get to the right unit that you can convert to a different system, but you need to do it a little bit different. That's true dimensional analysis that we'll talk about next class. You can try to, guys, listen, I'm not teaching you any new math. You've all been taught this stuff before, right? It's not brand new. I'm just adding on to the skills that you've already been taught. Okay? So, back to your notes. On the sig figs. How many of you had Miss Sanders last year and she attempted sig figs with you? Right? How many of you remember sig fig rules? You want to teach?
Nope.
Sure. Okay, so first the why or the what. Sig figs are important measurement recordings. All right? So why do we use sig figs? Because when we report measurements, we want to know how precise your instrument was or is that you're using. Does that make sense? If you're building something, if you're measuring something, if you're going off somebody else's work, you want to know how precise the measurements were that they used for their readings before you go off and build it yourself or do it yourself. All right? This is where sig figs come into play. All right? And so what we will do after this unit is multiply, add, subtract, and divide by sig figs, by measurements. But first, you need to know, well, what is a sig fig and how do I find significant figures? Significant figures, same thing as sig figs, just an abbreviation, okay? So there's 5 rules to figuring out if a number, a digit, is significant or not. I'm going to write them up here because it's a little bit easier, but follow along in your, so there's 5 rules, there's 5 slides there. I'm going to go by slide. You ready? Rule number 1, the easiest rule out there. What does it say? Non-zeros are always significant. So you'll count these. Any non-zero is always significant. Which means if I have an example of 243 millimeters, the question will be, in this measurement, how many significant figures are there? You would say 3, because of rule number 1 means none of these are all non-zeros, so they are all significant. Everybody got that? That's the easiest one. All right? If I have 2 liters, how many sig figs are in that measurement? 1, because it's a non-zero. All right? Rule number 2. They increasingly get more confusing. Just heads up. Rule number 2 is your, what I call your sandwich rule. Your sandwich zeros. All right? So we've pretty much taken care of every digit 1 through 9. Yes, every number 1 through 9. The rest of these rules deal with zeros. And this is where they get confusing, okay? Is this 0 significant or is it not? So the sandwich rule. A sandwich has, well, my sandwiches have 2 pieces of bread, right? Most sandwiches do. Which means the bread are other sig figs. That bread in your sandwich is other sig figs. So what I'm saying is, zeros have to be sandwiched for them to be significant. Let's have an example. I have 1001 something, doesn't matter. How many sig figs are in that measurement?
Four.
There's 4.
So by rule number 1, there's two. Because of rule number 2, these are sandwiched, so they are all significant. There's 4. Yes? What about 101?
3.
Right? 2 non-zeros, 1 sandwich. What about 100?
1.
Because those zeros are not what?
Sandwich.
They're not sandwiched.
So if
So-
there's like 4 or 5 zeros on 3, there's 1 and 2 at the end with all.
Yep. That your sandwich can be huge. Still sandwich. All right? But you need those 2 pieces of bread to sandwich them in.
Just looks like it's shiny.
What if it's like 1, 1, 0, and then
So let's say we have 1010. 1010.
3.
How many sig figs?
3.
2 non-zeros, right? Is there a sandwich in there?
Yes.
There's 3. Is this 0 sandwiched? It is not. 3.
does it still count if there's decimals?
That's what we're about to get into.
Oh.
The decimals make it tough. Yes.
So if it was like 1,100, like 1,101, then it would still be.
All 4. Yeah, because that 0 sandwich. All right. Rule 3 is the rule that's been getting everybody. Okay, because there's 2 parts to it, and both of them need to be satisfied for the 0 to be significant. All right. So we have final or trailing zeros that occur after the decimal. You all see how there's 2 parts to that. Both of them have to be true for a trailing 0 or a final 0 to be significant. All right? So let me give you an example. I have 1.00. How many significant figures are in that measurement? There's 3. Non-zero. Are these sandwiched zeros? They're not. However, final after the decimal. These occur after the decimal and then the final numbers. So now they are significant. Yes?
So they have to be directly after the decimal. right?
No. They have to be the final numbers after the decimal. You ready? I'll give you an example here. You
That
ready?
makes sense.
So let's say I have 2.0010. Actually, let's do this. 0.0010. How many sig figs?
2, 1,
4. 2.
2, 1, 4,
5, 7,
2,
3, 4, 2.
2.
Okay, you ready? So you guys have all done proofs in geometry?
Yes.
Like this is true. Some of them hate. I didn't mind them. I didn't like math, but those I didn't like. But some people, I've heard horror stories about proofs. Think of this like a proof. Like, go through the rules and tell me why something is significant or not. You ready? So, rule number 1, non-zero, right? Rule number 2, sandwich zero between other sig figs. Well, right now there's no sandwich, right? With other zeros. Rule number 3, final trailing zeros after the decimal. So here's your decimal. Are those final zeros? Is that a final zero? So how many sig figs? 2. Now, does this final zero sandwich anything else now? It does not.
Wait.
It can.
So even if it's like 1.7 zeros, all 7 of them are zeros.
Yep. Yep. Because if you think about it, these are all measurements, right? Those 7 zeros were in my measurement. It just happened to fall exactly on 1. But that doesn't mean my instrument was that cheap. Can you like visualize that? Like, it's a super expensive tool if it's measuring 7 zeros. Okay, and I want to record that.
What is like? Because one of the numbers like 4,003.00, right?
On this example,
Yeah, on the same thing. I just
so 4,000. What is it?
so that's 4003.00.
003 point what?
00.
Okay, how many sig figs there?
6.
So go through your rules. Non-zeros, sandwich zeros, trailing zeros after the decimal. All of them are significant. Yes.
So wait, you're telling me if the number ends in a 0, period, all
After
other-
the decimal.
After the decimal, yes. All other numbers are just instantly significant.
No. So they're
Like this
Like-
one.
Like say if you had like 6, 0 point, like infinite number of zeros, that instantly means that that first 0 was also significant.
So
Because
if y'all were paying attention up here, this used to be a 2, right? And then I erased it for a reason. So this is a 0, which means these are the only 2 significant ones. However, if we change it back to the 2 that I originally had, now what did I just do? I made a sandwich.
So, but like if you got rid of the 1, all of them would be sandwiched.
Yeah,
so.
all significant.
Yes.
Yes.
If they're all
That's
like
what I'm
zeros,
saying.
Yeah.
So if there's all zeros after the decimal, only the zeros count.
Yeah. And
So
that's what
like-
she just asked, because that shows precision of my instrument.
So like if it said 20.000, they'd still all be sandwiched. That's what I was asking.
Yep.
The,
Yes, ma'am.
So it's the 0 after the decimal and then the 0 at the end.
Has to satisfy both rules, both things. So if I go back to my original, right?
Yeah.
So these are not significant right now because they're not final and they're not sandwiched, non-zero. This one is significant because it's the final after the decimal.
Okay, so why does that first 0 after the decimal a final number?
Because they're after the decimal. And technically it's sandwiched.
Sandwich with the 3, right?
Because this 0 is significant now
Uh-huh.
and this 3 is significant.
Okay,
So sandwich rule too.
okay, cool.
Okay?
so if the string was at 0, they would still all count, or no?
Mhm. Yep.
So, wait, I was confused on what you said about his example, like the 20.000. So the 0 after the 2 before the decimal would become significant?
Because it's sandwiched.
Okay, so it could be sandwiched with another 0. Oh.
Guys, listen. I know some of you may not get this right now, but I'm going to repeat what I just talked about over here. Was The reason we have significant figures is to report the precision of a measurement. Yes? Keep that in mind. Right? If all of these zeros after the decimal we didn't report, then we're not reporting the precision of our instrument, which means someone may not see it as valid. Like they may not want it because it's not precise enough. If you're trying to sell your work, everything goes back to money, right? If I put all of these zeros in, you may be thinking that's just redundant. Why are you putting all those zeros? That's silly. It's a waste of time. But is it really? I'm telling you that I have an instrument so precise that it measures 5 spots past the decimal. It just so happened that this measurement was right on the nose of 4003. But that doesn't discount the precision of my measurement. That's why those zeros are now significant. All right, hopefully that makes a little bit more sense than what it was before. Yeah.
You told her if you change the 3 to a 0, it would sandwich.
Yeah, because it's sandwiching with the 4.
Yes, 'cause you're sandwiching.
You're sandwiching it
You could
to the 4 with your last
zeros in
digit.
the- Sandwich the zeros in the middle.
They're already sandwiched.
No, you told her basically if you change this to a 0, then this is significant. You could do that.
They're already significant.
So if that changes to a 0.
Mhm.
So
It
zero.
would be sandwiching
But listen,
with
listen,
4
listen.
and 0.
The final zero.
So I think there's, hold on, that's good. Some of you are getting confused. You're thinking that there has to be a sandwich on the right side of the decimal and a sandwich on the left side of the decimal. That's not true. It's all one big sandwich if we're going to do the sandwich rule. Okay? So if this does change to a 0, these were already significant with that 3. These were already significant because they're trailing zeros. Trailing zeros is plural. Okay? Let's get into a few examples. All right? Go to your homework, page 5. And I believe it's section 3. Yeah, go to section 3 where you're counting sig figs. You're not giving me, you're just giving me a number. How many significant figures are there?
Oh, that's notation. Okay.
No, section 3.
So
Go to section 3, you're just counting up the sig figs in that section. So you got a scientific notation, it's just that first number. Because scientific notation just adds zeros.
So you just move it 7 past the decimal 7.
So like this would be 10.
Because you're just adding zeros.
Yeah.
So for the scientific notation one, rule 4 is placeholders are not significant. Placeholding zeros are not significant. What are placeholding zeros? If you look at the number 100, how many sig figs here?
3.
One.
There's no sandwich there. It's before the decimal. And these zeros are placeholders. So placeholding zeros are not significant, but are they important?
Yes.
They are important. Be careful of that. I'll show you an example here in a little bit. If you do this into scientific notation, everybody watch. 1 times 10 to the second. What did I change? Nothing but the notation. How many sig figs here? Still 1. That's a 10. But this is scientific notation. When you turn it into standard, it's just 100.
So you're only talking about what's being multiplied
Right.
by the 10.
If I go something like, I don't remember what the example was, but something like 3.45 times 10 to the 7th,
Yeah, it was 3.41 was all.
right? This 7 just means I'm moving this to 7 spots to the right. And the only number I'm really adding is placeholding zeros. Well, number 4 says placeholding zeros aren't significant. So I don't even need to do the math. 1, 2, there's 3 sig figs there. All right, go ahead and try to do a couple more in that section. About 2 more minutes, and then we'll move on to adding and subtracting and all that good stuff. Say that again? Yeah. Or the centigrams? Centimeters or centimeters?
So I was saying I should work under here.
There's no, where's your sandwich? Where's your other piece of bread?
You got the same. So at least we're understanding what she's saying. Was this like over here? Is this over right?
No. Oh, yes. Yep.
So if there was a 0
That's
plus
why
4, then
Yes. At least it was, I checked like 4 or 5. You got those.
Everyone should understand.
If you see your grade, it's 75. Just make sure it's go to the grade real quick, and it highlights it a certain color to sleep. So yours will show up late. You can turn in before the deadline, then we'll change it back. Just remind me. All of today. Hmm? Right here? They all are. Yeah, everything here is significant. Yeah, those are all significant.
So if there was a 0 to the 4, would only the zeros after the decimal be significant?
Now, rule number 5, let's move on to with your notes. Rule number 5, we don't really pay much attention to in here because it says, if you read it, it says, really any conversion factor has an infinite amount of sig figs. We technically apply it, we don't talk about it much because it's an infinite amount of sig figs. We're not concerned with that. All right, and we'll talk more about, you're going to get your amount of sig figs from your answer. And that'll make sense now that we're going into adding and subtracting. Okay? All right. So this is the part where it starts to get confusing, right? This is the confusing part. Because we have a set of rules for adding and subtracting sig figs, and we have a little bit altered set of rules for multiplying and dividing sig figs. All right, so if you're looking at those slides, all right, make sure you get to those. Because when we add and subtract sig figs, that means you took a measurement, this group took a measurement, this group took a measurement, and we need to add them all together to figure out the total volume of something. All right? What we do is we are only concerned with the numbers after the decimal. What do I mean by that? So let's say I'm trying to add 2.5, 2.01, and 3. I know this is a little bit different than what's on your paper, but it's the same concept. I don't know, it's on. Okay? So, when we go to add these, obviously you all passed the 3rd grade, and so you can add that together, right? So, let's get a calculated answer. Your calculated answer is 7.51. However, if you write that down on a test, it's going to be wrong. Because these are measurements, we have to use sig fig rules. The sig fig rules for adding decimals is that we're only concerned with the digits after the decimal. Okay? For both of these now, there's a rule about the weakest link. What that means is we can only report to the amount of sig figs in the weakest tool, the weakest measurement. And we all talk about precision, right? The more decimals, the better the instrument. Yes? So which one up here has the least amount of sig figs in its decimal spot?
3.
This one has 0. This one has 2. This one has 1. Is it, you all following that? So when I go to report my answer, according to the weakest link rule, how many decimal spots can I have? Weakest. I can't have any. 0. Because this tool didn't measure any decimal spots. Does that make sense? So according to the weakest link rule, I can't have any decimal spots in my answer. I can have as many whole numbers as I need. Because when we add and subtract, it's only about after the decimal. So all of these whole numbers don't count for or against my sig fig count. You follow that? Only the digits after the decimal, which means I can't have any. So how do I turn 7.51 into only one sig fig? Well, so this 7 is going to be here no matter what. I can't do anything with that, so what does this 5 do to the 7?
Round it up.
That rounds that up to 8. So 8's my answer, right? Hold on one second. Keep that in mind. Is 8 my answer? What do I have to have? Oh, I'm sorry. Is 8 my answer?
Yeah.
It is, because I can't have any decimal spots in my, so this is my answer. All right, now what was your question? So then let's, you guys kind of follow that example?
Yeah.
Let's change it slightly. Let's change it slightly. Let's say it's 3.00. So no longer do I have 0 sig figs. How many sig figs do I have now? 2. All right, is that kind of what you're asking? So now, what's my weakest link? The 1. So now I have to have 1 decimal spot. So now my answer is 7 point. Well, no, I'm not using that anymore. I'm using this 1 to do what with the 5?
Keep it the same. It rounds down.
7.5.
So if it was 3.1 and if it was 2.5, what would be the weakest?
2.5 and 3.1, you'd be able to use all your digits.
You count up the digits, whichever one has the lowest amount. If they're all the same, that's the number you use. Doesn't matter.
What if your number that it adds up and 3 digits after the decimal place, but 1 in your weakest number is 1. But say your last digit is 8 and the 1 in front of it is a 1.
So let's do this. Let's say you're adding up and you have an answer of 3.94 and you're only allowed to have 1 sig fig. Let me say that again. You added everything up or subtracted it. Your calculated answer is this. But you're only allowed to have 1 significant figure after the decimal. You following that? So this number doesn't matter because it's before. This number, let's change this to an 8. Let's say that, so this is the one that you need to round to, correct? Well, this 8 does what to that 9? Rounds that up to a 10, which makes that a what?
4.
That is that correct or incorrect?
Correct.
I have to have 1 after the decimal.
Oh, 4.0.
So I need to add that significant 0.
What if there's a 9 right
No. So you can have as many numbers as you want here, because remember, it's just rounding rules that you learn in, I don't know, 4th or 5th grade, just basic rounding rules, right?
Do you always round 1/5 to the number after?
Yes. So if it's a 5, you round up. If it's a 4, you keep it the same. Yes. All right? So that's adding and subtracting. When we multiply and divide, it's slightly different. We look at all sig figs in your measurement. The weakest link still applies. So now let's say I multiply 2.0 times 4.5 times 3. So this measurement has how many total sig figs? This measurement has how many total?
2.
This one has what?
1.
So when I do this answer, how many sig figs can I report?
1.
Weakest link? 1. Okay? So let's say, I know some of you don't have calculators, that's not, I'm not worried, I know you can all punch stuff in the calculator the right way. I hope you can. Let's say that this comes out to be 8.45. It doesn't probably. Let's say it does. Okay? How many sig figs do I have here? 3. How many am I allowed to have?
1.
Which means I need to have, there's 1. What do I do with that? 4? I use that to round that 8. So 8.00, right?
So you keep the zeros out.
How many sig figs am I allowed to have?
1.
How many do I have now?
3.
You still, oh yeah.
You can't have.
8.0? How many sig figs is that?
That's still 2.
How many sig figs is that? Is that my answer?
Yeah.
That's what I'm saying. Don't just start adding zeros after your decimal because it's fancy and you think you're doing the right thing and there are decimals here, so I need to put decimals there. You just added sig figs where it's not needed. So it's just 8 because I'm only allowed to have 1 sig fig. Yes?
So, the answer would have come out to 27 even, so how would that work if you can only have 1 sig fig? Would it be the 207 that you kept? Because it would have come out to 27 even.
So you.
There's 1 sig fig. Use that to round.
So if it's a 1 you just round it.
Now, I'm glad. Listen, because some people would have put 3. However, say these measurements are about what I owe you in money. And the calculator came out to 27 something. But through sig figs, you said I only owe you 3. Is that fair? Is that right? That's why when you say that zeros aren't important, placeholding zeros aren't important, that's not true at all. Now I owe you 30, which is a lot closer than 3. See what I'm saying? And I'm going to see a lot of you, hopefully I don't, but I will see you're going to come up with an answer of like 2,940 with 2 sig figs, and you're going to write down, calculated, you're going to write down 29. Is that right? You forgot your place holding zeros. You need to have those.
So you round, so you keep that, but you round, and then you add the zeros, so it makes a bigger number, but the zeros don't count because they're.
Where these your calculated number and your sig fig number should be very close. Obviously, the higher number you get, the less close they might be, but yet it still makes sense. Think of it in terms of money. Like if somebody owes you this, like that's
Close.
close enough.
Okay.
Okay? So, go ahead. This is your time to work. I'm going to stop the video. Once again, now some of you are thinking like, yeah, I actually might watch that video that he was talking about before. And scroll through it. And just so you know, guys, there are millions of more entertaining videos out there of significant figures and of metric conversions. By all means, go watch them if you don't wanna watch mine.
3, 5, and 6.
Let me stop this, I'll be right back.
We did 3. That's when we worked on getting, and then 5 and 6. 5 is the one we started.